Till now, we have been discussing about image classification and the specific architectures that helps us classify an object present in an image. So, image classification involves assigning a class label to an image. For example, in this slide, the first figure is an example of image classification, wherein which I will provide an image to my model, and the model has to identify what is the object present in our image. Is this an image of a cat or not? So that is how a image classification works. And till now, the architecture and the coding example we were looking into was associated with this first task in computer vision, which is called as image classification. Now, you also have another common task performed in computer vision problems, which is object localization. The object localization, as you can see in this figure, involves drawing a bounding box around one or more object in an image. In this specific example, we have only one object in our image, and I am having a bounding box around that object. Now, this is an example of classification plus localization, because here there is also a bounding box drawn around the object in my image, but also it is my model is predicting what is the object present in that image. In this case, it is a cat. Then we move on to some more advanced challenges in computer vision, of which one is object detection. Object detection is more challenging, and it combines these two tasks, that is classification as well as localization, and it involves more than one object present in the image. So basically, this example is also an object detection because I have classification as well as localization, but this object detection becomes more of a challenging problem when you have more than one object present in that image. For example, here in your third image, you can see that we have obtained the bounding boxes around each object of interest in our image, and we have also assigned them, or my model has also predicted the corresponding class label associated with those objects. Now, there is also another computer vision task which is also quite famous, which is the object segmentation, or also called as instance segmentation or semantic segmentation. Here, instances of recognized objects are identified and highlighted with the specific pixels of the object instead of a bounding box. So in this case, the difference is that I am highlighting the specific pixels of the object, whereas in the object detection, I am identifying the object and then drawing a bounding box. So these are the four different categories, or I won't say 4 because the second example is also a type of object detection. It is just that it just have one object of interest present in that image. So the classification, object detection, and instant segmentations are 3 different areas in computer vision which is very popular. Apart from that, we also have landmark detection, pose detection, which are also quite famous domains in which computer vision techniques are used. So let us start first with object detection, that is identifying the object of interest within an image and then drawing a bounding box around that object, as well as predicting which class or which label that particular object belongs to. So let us first look into examples where I will have just one object of interest in my given image. Let us quickly understand what is the basic difference between object classification and object detection. Now we are already familiar with object classification. For that, I will have a ConNet, right, which has number of hidden layers, and then to the end I will have fully connected layers, and to the very end I will have my output layer. So this is a typical example of a convolutional neural network used in an object classification problem. Now assume that I'm building an object classification that is to be object classification model that is to be fed into say a self-driving car. So in that case, for a self-driving car, if I am building an object classification model, some of the categories of the labels I can expect are pedestrians, right? Car, truck, background, right? And many more categories. For the time being, let us assume that we just have these 4 labels or the 4 categories. So in that case, I will have a data set which consists of images of pedestrians or cars or trucks or just background, which will be trained using our convolutional neural network. And if I am just having 4 classes, then in my output layer, I will have a softmax unit, which will have 4 neurons, as you can see. So this is how a typical object classification works. Now imagine that I wanted to localize the car present in this image. So this is the typical convolutional neural network we just discussed. But now I wanted to localize, that is, draw a bounding box around the object of my interest. In this case, suppose it is car. Now to do so, you can change your neural network architecture to have few more outputs in your output layer, so that now I have one unit which actually is a softmax that will tell me what the object is. Is it a car or a pedestrian or not? And you will have another unit which will output a bounding box. So typically a bounding box is represented by 4 coordinates: bx, by, bh and bw. And of course, the image or the data set used to train that particular model should also have a bounding box around the object of interest. Only then your neural network can actually learn the bounding box and thereby can predict the bounding box on unseen images. So for an object detection problem, our data set would be quite different. So our training data set will now contain the images. It will also have the target label telling if that image is a car or a pedestrian or a truck and so on. And it will also have the values bx, by, bh and bw in order to represent the bounding box within that image. So my training image or my training data set will look very different from what I used to have for an image classification problem. So now the question comes, given an image, how do I annotate that particular image to have a bounding box around the object of interest? So in this case, my object of interest is a car, and for the time being we will work with the most simplest case, which is just one object present in the image. So usually in order to annotate this image and provide it with a bounding box, we take this point to be 0, 0, the other end of the image this to be 1, 1, and the bounding box is represented by a value bx, by, which is nothing but the center of your object, approximate center of your object present in that image, and the bh would be here, that is the height of that object in that image, and bw will be the approximate width of that object in my image. And this is what constitute the 4 values which will form my bounding box. So given my target label and my bounding box value, now we can use a supervised learning algorithm to make my algorithm or my model output not just the class label but also the 4 parameters that is associated with my bounding box. And this is how basically a object detection works. Now let us see what the target y value, our target label y, is going to be in an object detection scenario. So the target value y is going to be a vector where the first component is PC, and it is going to tell us if there is an image, if there is an object present in that image. So if there is an object present in that image, then PC will be equal to 1. Now, if PC is equal to 0, that means there is no object present in that image, or it is just a background image. For example, in the case of a self-driving car, if PC is equal to 1, it indicates the presence of an object within my image, which could be either the object pedestrian, car or truck. But if PC is equal to 0, it means there is no object present in that image, and therefore it is an image with just have a background. So if there is an object present in the image, we also need to have the bounding box coordinate for that object. So we should have BX, BY, BH and BW. Finally, we will also have the output classes C1, C2, C3 if again PC is equal to 1. So PC indicates the presence of an object in an image, and definitely if there is an object present in that image, that object has to be associated with a bounding box. So you will have the values BX, BY, BH and BW. And obviously if there is an object present in that image, that object has to be associated with a label. Now suppose that I have an image which has an object car in it, and of course it is annotated to include my bounding box. Now for this particular image, the target Y value will be equal to PC will be 1 because there is a presence of an object, and whatever the value of BX, BY, BH and BW is, right? And since it is a car, it is an image of a car, I am saying that it belongs to the class 1. So this will be C1 is 0, C2 will be 1 and C3 will be 0. So this is how my target Y value appears for this particular image. Now suppose if my image has no object present in it. In that case, definitely the value of PC will be 0 and the remaining values are treated to be don't care conditions. That is, technically I don't worry on what the remaining values of my target Y is. Now let us see what the loss function will be for my model that is trained in order to perform an object detection task. As we have discussed, if I'm taking the previous example, I will have my target Y value which has 8 different values, that is PC, BX, BY, BH, BW, C1, C2 and C3. And for the ease, let me call this as Y1, Y2, Y3, Y4 and finally Y8. So we know that irrespective of what neural network we are training, we always have to find the loss function. And the loss function is nothing but the predicted value of y minus the actual value of y. And to make the negative positive implications, we always square it. So in this case, my loss function will be equal to y1 hat minus y1 the whole square plus y2 hat minus y1 the whole square plus up to y8 hat minus, sorry, this is y2. So y8 hat minus y8 the whole square. That is, technically I am subtracting each of my numbers in my target y value with the predicted values of y, right? And this is when my y1 is equal to 1. So this is technically when I have an object of interest. That is when y1 is equal to 1, or as we say, PC is equal to 1. Now if y1 is equal to 0, that means there is no object present in that image. Technically, I am not interested in any of these values y2 up to y8, and I am only interested in knowing if my neural network output the value of PC, which I have resonated with y1, correctly or not. So technically, I am only interested in y1 hat minus y1 the whole square.